All right, so 36 moles, we would convert that to atoms from the moles. 6.022 times 10 to the 23rd over 1. Now remember that you should know how to put that into your calculator, that scientific notation. If you're still struggling with that, which I didn't really have many people ask me for help with that on the test, so I'm assuming that you guys are pretty efficient with it. But if you are still struggling, then see me about it. Let me know, and I can show you how to put it into your calculator correctly so that you're not getting big numbers. So if you're getting numbers over 23, then that should be a clue to you that, so when I say over 23, I guess if it's like 24, 25, that can still be okay. But if you're getting things like 54 or 40 something, that should be a red flag that, oh wait, I probably did this wrong, okay? So you're going to want to correct that, okay? Figure out what's wrong, all right? All right. How many moles in 2 times 10 to the 18th atoms, right? So 2 times 10 to the 18th atoms to the moles from the atoms. Now this is just the opposite, right? 6.022 times 10 to the 23rd over 1. Okay? All right. So I'm not going to do all of these, but let's look at letter F here. So 2 times 10 to the 24th atoms. How many grams is that? Okay. So 2 times 10 to the 24th atoms. Now this is actually of a substance that we need to know what that substance is because we have to calculate the molecular mass of it. Calcium phosphate. Ca3PO4 Okay, so we're going to convert this from atoms to grams from the atoms. And you can always do that in just one step because we know the relationship. What's the relationship between atoms and grams? 6.022 times 10 to the 23rd atoms for every, find it here, right? For the grams of the mass of that thing. So we'd say calcium, phosphorus, oxygen. Those are the elements. How many calciums? 3. How many phosphoruses? 2. 2. How many oxygens? 8. Okay? So calcium.
120.
Well, here, let's just do it here. Okay. So we can see how this is. So calcium has a mass of 40. So we'd say 40 times 3 gives me 120. Phosphorus has a mass of 31. So we'd say 31 times 2. I get 62. And oxygen is 16 times 8. Gives me 128. Okay? And then I simply have to add those together. 128 plus 62 plus 120. 310. Okay? That's the mass that I'm going to use here. So that's the gram mass. 130 grams for every 6.022 times 10 to the 23rd atoms. Okay? And then I'd say this times 130 divided by 6.022 times 10 to the 23rd. Yes? Say it again. Oh, gosh. I told you have to be dyslexic to do chemistry. But you still have to put your numbers in correctly. Okay, so it's 310. Yes. Okay, so that's simple conversions. Okay? Balancing chemical equations. How do you guys feel about those? Good. Okay. Stoichiometry. Okay. So I'm assuming that's where you guys are mostly struggling. Okay? And stoichiometry is no harder really than these right here. These are just simple conversions. The thing that you have to understand about stoichiometry is this is the heart of stoichiometry. This is stoichiometry. The moles of one thing, A, to the moles of another thing, B. I'm going to make it real simple for you. Okay? So, GMMG. GMMG. That, right there, GMMG is a guide to answer any stoichiometry question. Okay? That will be a guide that would answer any stoichiometry question you might have. So I'm going to fill in a little more information. What I mean by this is G of A to M of A to M of B to G of B. Okay? So the G there stands for grams. The M stands for moles. Okay? So there's essentially two parts of this, the A side and the B side. So A is one substance, it's the initial substance, and B is the final substance that you went to. Okay? So stoichiometry is simply A to B in units of moles, because you can only switch from A to B in units of moles. Could I ever go from G of A to M of B? No, I can't do that. I would skip this, right? I can't do that. I can't go from M of A to G of B directly, because I would skip this. I can't do that. So this is the procedure I have to follow. Okay? I don't have to follow all of it. It just depends on what the question asks. If the question, so let's say this is your 2H2 plus O2 produces 2H2O. Let's say you start out with 0.78 moles of O2. Okay? And you want to find how much hydrogen will react with that. Now I need to specify what unit of hydrogen I'm looking for. So if it was moles of hydrogen I was looking for, then coming back to this guide, where would I start? Would I start here at G of A? No, because that's not where I'm starting. Where am I starting? Okay, so I'm going to eliminate G of A. I'm going to start here at M of A, and I'm going to go to where? M of B, because moles of hydrogen. I started with moles of oxygen. I'm going to go to moles of hydrogen. Just one step, a one-step process there. So I eliminate both gram steps. They're unnecessary. Okay? So I would just say 0.78 moles of O2 to the moles of H2 from the moles of O2. Where do I find this mole-to-mole relationship? Good. What goes on top? 2 over 1. Okay? So that's how I would do it. Now, what if it didn't ask for the moles of hydrogen, it asked for the grams of hydrogen? Where do I start? I don't start with G of A. So I'm going to still eliminate G of A, because where am I starting? 0.78 moles of O2. They gave me that as my starting point, not grams. If I started with grams, then I would have to start here. But I'm starting with 0.78 moles of O2. So I start it the same way, 0.78 moles of O2. Okay, now what? What's the next step? Moles of H2. Okay, but do I eliminate this G of B? No, because that's what they want, right? They want the grams of hydrogen. So I have to include that step. So moles of hydrogen to the grams of hydrogen. That's the process I have to follow. Okay? So this is simply a guide, a tool, GMMG. It's a tool you can use to answer stoichiometry questions. If you write it down, GMMG, and then when the question tells you this is what you're starting with, you find out, okay, am I starting with grams or moles? If I'm starting with moles, I eliminate the grams. What am I trying to find? Grams or moles? If I'm trying to find the moles, I eliminate the grams. If I'm trying to find the grams, I go to the end. Okay? Now, if we had started with 7.8 grams of O2, okay, and I'm going to go to the grams of hydrogen, how much of this process am I going to use? The entire thing. I start here, and I'm going to go all the way to the end. Okay? Let's look at this earlier one. Moles of oxygen. What unit goes down here?
Moles of O2.
Okay, that's right. I always drop my unit. Always. Okay, whatever came before goes to the bottom. Moles of O2. What goes here? Moles of H2. Gram and mole conversions. Moles are always 1. You want to know what people put there commonly as mistake? Nope. That's not the most common mistake. Maybe sometimes, but that's not the most common one. The most common one in stoichiometry that they put there, 2. They'll put a 2 there because it's the coefficient. Why don't I put a 2 there? That's not the relationship. It's how many grams for every 1 mole. That's what I want to know. That's the relationship. If it was for 2 moles, 1 mole of hydrogen weighs how much? 1 H2, I'm sorry. 2. Okay? So if it was for 2 moles, it would weigh 4. So if you put a 2 and a 2 here, that's not the right relationship, right? It would have to be 4 and 2 or 2 and 1. This is the correct relationship. 2 grams of H2 for every 1 mole of it. That's the relationship. So whenever it's grams and moles, moles are always 1. When do I not use 1 for moles? When it's a mole-to-mole relationship. When it's a mole-to-mole relationship, I have to go where to find that relationship? The balanced chemical equation. 2, 4, 1. That's where I find it. Okay? So here is the process from going from the moles of O2 to the grams of H2. Okay? And in the last question right here, 7.8 grams of O2 to how many grams of H2? 7.8 grams of O2 is what I start with. And I'm going to go GMMG. I'm going to do the whole thing. Grams of A, grams of oxygen, to the moles of oxygen, to the moles of hydrogen, to the grams of hydrogen. Grams of O2, moles of O2, moles of H2. Grams of moles, moles are always 1. So right here I'm going to put a 1. I'm going to put a 1 there. 1 and 1. Gram and mole, gram and mole. Okay? Grams of O2. 32. 16 times 2 is 32. Each oxygen weighs 16. Grams of H2. 2. Each hydrogen weighs 1. Mole to mole relationships. Moles of H2 to moles of O2. What number goes on top? 2. 1 on the bottom. Those are based off of the coefficients from the balanced chemical equation. Okay? That's where they come from. So that's as far as it gets. You're not going to ever have to do more than that with stoichiometry. Okay? G, M, M, G. That's the most you're going to have to do. Okay? So when you're reading your question, identify where you're starting and where you're ending. And use your guide. GMMG. Where do I start? Where do I end? Okay, any questions or an example you want me to try? Something that might be confusing you. You guys feel a little better about it? Yeah? Okay. So should we move on?
Yes.
All right. Where are we going? Okay, so percent yield is very straightforward. It's the actual over the theoretical times 100. This equation is given to you on your reference material. Okay? The only thing that people struggle with is identifying what is your actual and what is your theoretical. So what are they? What's actual? How do I know if it's the actual or if it's the theoretical? What's the difference? Exactly. Theoretical is calculating it through stoichiometry. So if you do the stoichiometry and you calculate an answer, that is your theoretical. Okay? Because it's not truly the amount that you created, right? It's just a number that you calculated. So it's simply theoretical. What is the actual? Where does that come from? The question has to state it. It tells you. You created this amount in the laboratory. Or it says you produced 2.5 grams. So if you reacted this much hydrogen and this much oxygen, you produced 2.5 grams of of water. What's the theoretical yield? Or what's the percent yield? So they told you produced 2.5 grams. So to find the theoretical yield, I would do the stoichiometry. I'd use my 2.5 on top. I'd divide it by my theoretical, and I multiply by 100 to find my percent yield. Okay? So they're telling you in the question, you produced this amount. That means that's the actual yield. The theoretical yield, they're not going to ever tell you. So whatever they give you in the question will be the actual. The theoretical will always be the one that you have to calculate through stoichiometry. Okay? So that's going to be how you find your percent yield. Theoretical yields are always in gram amounts. Okay? So if they don't tell you to calculate the grams of water, that's because they assume you know you're supposed to. Because it's a percent yield. Percent yields are done in gram amounts, not in moles. So you'll never stop at M. You'll always go to G if it's for percent. If it's for percent yield, you always go to G. Because in the laboratory, we don't measure actual yields in moles. We can't do that. We measure it in grams on the scale, right? So you have to calculate the theoretical yield in grams. Okay, moving forward.
I'm really confused on gas laws, especially which ones you use them since there's a lot.
Okay, so on this review, I actually try to help you understand when you would use one type of gas law versus another type. So these are pretty straightforward gas laws, the ABC laws, right? Just solve for one variable. If it's Avogadro's law, V1 over N1 equals V2 over N2, my recommendation is always get everything off the bottom. So you can easily isolate the thing you want, okay? So N2 goes up here, N1 goes up here. So I get V1 N2 is equal to V2 N1. Now, whatever I'm solving for, I can easily isolate. What are the new numbers of moles? Well, N2 is equal to V2N1 divided by V1. So N2 equals V2N1 divided by V1. Go away. Thank you. I don't need all those reminders. Okay? V1. Okay? So that's how I'm going to isolate a thing that I want. Okay? Now, ABC gas laws are used when there is change. V1 to V2, N1 to N2. That's how I know I'm going to use an ABC gas law or the combined gas law. Because there's change occurring. The new volume, what is the new volume? What is the new temperature? Okay? The pressure changed to what? That would be indications that I need to use an ABC gas law or the combined gas law. Because once I enter into the ideal gas law, PV equals nRT, the ideal gas law is used when there is no change in the system. Okay? You are just simply trying to identify the unknown parameter. What is the volume of this gas? What is the temperature of this gas? When you're just trying to identify what one of those unknown parameters are within the system, not a changing system, but a system that is constant, that's when I use the ideal gas law. Okay? So I would use PV equals nRT for that situation. Does that help?
Yes.
Okay? Is there something else you want me to do with it? You want to do some examples?
Yeah, just a couple.
Okay? What gas law am I going to use for a question like this?
Ideal.
Ideal gas law, right? Because there's no change. There's no change in the system. It's just saying, what is the pressure of this system? So it gave me all the other parameters, and it's asking me to find that, that pressure. So PV equals nRT. I'm going to solve for P. P equals nRT over V. Okay? N, 0.987 moles. What's R? .0821 liter atmospheres over Kelvin moles. R is the constant, the ideal gas constant. That's a reference material as well. It's a number that will never change. So wherever you see R, you just put that number in. Okay? What is my temperature here?
27.
Okay? Plus 290, oops, 273. Okay? So I can't forget to add the 273 to get to the Kelvin temperature, because degrees Celsius are not acceptable. Because look, my constant has units of Kelvin. I cannot cancel degrees Celsius with Kelvin. Okay? And my volume here is 2.8 liters. Is that acceptable? Liters? Yes. Liters, liters, moles, moles. Okay, this is going to be 273 plus 27, 300. Oops, 273 plus 27, and I get 300. Okay, so 300 Kelvin, and my Kelvin temperatures cancel. So now I just simply have to do the math, right? Multiply everything across the top, 0.987 times 0.0821 times 300 divided by 2.8. Okay, so my pressure is 8.68 atmospheres. Okay, so that's how I would solve something. I first need to identify what is the gas law that I need to use. Okay, and you'll be given all the gas laws that you need except for the combined gas law. How do I find, if I need to use the combined gas law, how do I get it? What is it? Yes. So what is combined to get that? Charles and Boyle's. Okay? Charles and Boyle's law put together. Yes?
So, just like the relationship, the laws, whenever it's like V1 over N1, since it's like dividing, that means that it's like
direct.
Direct, and then indirect is when it's multiplied across.
That's right. A direct relationship would be multiplication. Indirect relationship.
No.
A direct relationship would be division, and an indirect relationship would be multiplication. So Boyle's law has an indirect relationship. Charles' law has a direct relationship. Okay? Meaning if I increase the temperature, the volume of the gas will also increase. Okay? If I increase the pressure, the volume of the gas will decrease. That's Boyle's law. Okay? Indirect relationship. Okay, what else? Chapter 6. I would hope chapter 6 isn't too difficult. But, I mean, it just has, you'll be given these equations. Okay, know how to calculate molarity per volume. You know what I'm going to do? I am going to post the reference materials here for you guys. Okay, so here are your reference materials. Okay, so I just went ahead and put them on there. Guess I need to rename that. Okay, so it's under that tab, reference material. So this will be what you have for your test. You can see that you have mass per volume right here. And it tells you mass of solute over the volume of solution. Mass of solute will be in what units? Grams. Volume of solution will be in what units? Milliliters. Okay? Just kind of like density. Grams per milliliter. Times. So basically it's kind of like the density times 100. Mass per volume. What if they gave you the moles? Just convert to grams, right? What if they gave you the liters? Put it in milliliters. To go from the liters to the milliliters, you divide by 1,000. Okay? Mass per mass percent. What are the units here? Grams, right? And on the bottom? Grams. Grams per grams. Okay? Grams per grams times 100. Okay? And that's how you get these. Okay? Here's your percent yield equation, actual over theoretical times 100. Another one in this is density. Moles per liters. Okay? Moles per liter. So that's right there. You know how to calculate molarity. So essentially with molarity, you're going to have more types of these questions than you will probably have any other type on chapter 6. Okay? Percent mass and percent mass per volume and percent mass per mass. You might have like maybe one question of those. Okay? And then you're going to have a few of these. And then with the colligative properties, you're not going to have to calculate any of this. Okay? Not on the test. I think on the homework you had to, but on the test you don't. You just have, but I think you might have some questions about colligative properties. But
can you show an example, like when it gives, like, find the whatever, when there's like this plus this dilution or whatever? There was like something on the homework that was like, it was like the molarity of like 0.1 moles of whatever with, or maybe it was.
was it a dilution question?
It might have been, I think so, unless it was. No. You know, yeah. Yeah, but
Okay,
it would
let's clarify this.
Yeah. Both times. Both times I did it in
So how many grams of a solid are needed to prepare 3.5% of mass over mass solution that has a solution mass of 2.5 times 10 to the second gram?
This one?
Yeah.
Is that the one?
Can you actually scroll up a little
This way?
bit? Yeah, I think it might have been number 3. Yeah.
Calculate the mass per volume percent for a solution 2.23 moles of magnesium chloride in a 447 milliliter solution. Got to convert that to grams. Okay, so I would need to take that 2.23 I need to say 2.23 moles of magnesium chloride and convert it to the grams of magnesium chloride from the moles. Okay, moles are always 1. Grams, I'd have to find the mass of magnesium chloride, and then I could use that number divided by 447 times 100. Okay.
And then can you scroll back down to like 5
Yep.
and 6?
how many milliliters of a 4% mass per volume solution would contain 1.2 grams? So for a question like this, you would say 1.2 grams. That's what you're starting with. And it's magnesium nitrate, which isn't really all that important, but it's 1.2 grams divided by your volume equals, and that's times 100, is equal to 4%. So first thing I would do, I'd divide by 100, okay? And I would get 0.004 is equal to 1.2 divided by V. And then I could move V up here, and I would get 1.2 equals that, and then I could move this down here, 0.004, and I could take 1.2 divided by 0.004, and it would tell me the volume. Okay? Oh, we're going to do this homework, huh? Okay, calculate the volume in milliliters of 0.744 molar KOH. So this is a molarity question. Well, might as well. Okay, so we have molarity equals moles over liters. Okay, I want to solve for the volume, which is L. So L is equal to, if I move L up, move M down, I get moles over molarity. And then I get 0.072 divided by 7.44. Molar, this is moles. Okay?
And
0.74.
Zero.
It's the same thing. It's the same stuff.
Oh, 0.744, I'm sorry. 0.744. Like that, yeah. Okay.
For real, I know. Yeah. On the homework.
Yeah,
Oh,
it's-
yeah. I have no idea.
Yeah.
I was so frustrated. And I was like,
We were all the same.
So, how would we write that with no decimal places? Would that just be, I got 0.967?
Okay, so I'll give you a hint.
so what?
When I put like no decimal places and all that, I honestly started getting rid of all that because it honestly doesn't matter. You can put the entire answer from your calculator. The computer has no idea. It doesn't discriminate between decimal places, no decimal places, nothing. It calculates an answer and it matches your answer to that answer. And it doesn't care about significant figures, nothing. So if you just put your answer in as many decimal places as you want, it's gonna be fine.
Can you go through chapter 6, 0.5 and 0.6?
Like, since we don't have to. We don't have, he said we don't have to calculate.
Chapter 6, Part 5. Collegiate properties are, this is just telling you what the collegiate properties are. What does it mean to be a collegiate property?
Goes along with it?
It means that vapor pressure, boiling point, freezing point, and osmotic pressure, those will change, the properties of those will change based on the amount of solute. How much is there? So if I increase the solute, the freezing temperature will go lower and lower and lower. If I increase the solute, the boiling temperature will go higher, higher, and higher. The vapor pressure will go lower, lower, and lower. Okay? Does a 0.5 molar solution of glucose have the same effect as a 0.5 molar solution of sodium chloride? No, because glucose is one particle. Sodium chloride is
Another.
2 particles. Okay? So it's kind of those ideas of how does this collegiate property stuff kind of work. Okay? It works based on the amount. It's non-discriminate on what is present. It just cares about how much there is. Okay? Okay. Honestly, I don't think you're going to... Well, you might see something about this. But isotonic, hypotonic, hypertonic, if anything, it would be just like one question in the entire test that you would have on something like that. Okay? No change if it's isotonic, right? So is the water going to go in or out? If it's meaning iso, meaning the same salt concentration inside and outside, so the water is going to stay. It's not going to go anywhere. Okay? Hypotonic, the cell will swell up because hypo means low salt. If you have a low salt solution, then your cells are going to take in water. If you have a salty solution, your cells are going to crenate. They're going to shrivel. Okay? You're going to get your pickle. All right? That's something you haven't tried yet.
I tried it, I think,
Oh, never mind. She did try it.
you put it in syrup, and then you put it on.
Oh, put it in a
vinegar,
syrup.
And it just gets fat. They just call it fat. It's hypotonic.
Yeah, cool. That's right. Okay, I'll never doubt you again. Okay, chapter what? Where are we going?
Oh man, yeah.
Let's just
Can
go.
you do that first part?
We should just like read
Yeah.
after. Like, yesterday when I was doing the homework, I was like,
But both,
Yeah.
both of them, it's for no solids and liquids. It's just for the,
I looked up all
for
the
the
ones that didn't have all
equilibrium.
those. Like,
What did they say?
Yeah,
Sorry?
right.
Even some of those, I was like, don't add solids or liquids.
We just did it
That's
now.
only for equilibrium or also for the.
That's only for equilibrium. Okay, it's for equilibrium. Okay. Know how to write a rate expression. Okay, and I showed you the rate expression right here. That's the general form. When would I ever change N and M to something else? If they tell you what they are. Do I use the coefficients? No. Why is it confusing? Why am I asking you that question?
Because
That's a common mistake.
whatever the.
Why is it a common mistake? Because with equilibrium, you do use the coefficients. Okay? So here's equilibrium. Did I use the coefficients here? Let me bring it down. I sure did. Okay? Because that's when I use the coefficients. Do I use the coefficients in rate? No. I only raise it to its order if I am told what that order is. Otherwise, this is my answer. Do I have to calculate anything with this? No, you don't. Okay? That is not part of what you are trying to do. All you are trying to do is identify how to write a rate expression. How's that going to help you? I have no idea. That is the mandate, though. Okay? If it was up to me, I'd make you calculate it, and then I'd say that can help you one day. But otherwise, this is all that you're mandated to do. Okay? So, you just have to write the rate expression and be able to identify what it is and understand that it's only reactants, whereas equilibrium is products over reactants raised to their coefficients. Now with equilibrium, I might give you the data, right? So here I give it to you. NH3 is 0.034 molar, N2 is 0.066 molar, and H2 is 0.043 molar. And then you're going to have to plug those in, right? So 0.034 squared divided by 0.066 divided by 0.043 divided by 0.043 divided by 0.043, okay, or 0.043 cubed, either way, okay? So however you guys want to do that in your calculators, you're going to get this answer. So I put that there so you could practice getting that answer. Make sure that you can find the correct answer. Yes?
I took a picture of a question because I didn't understand it. There was like a reaction of A plus 2B plus C yields B plus 2E. Is the first order in reactant A, first order in B, and second order in C? What is the rate?
So this is a homework question?
Yeah. No, I didn't get like first order and second order.
That's what I read. Everyone's like, get a phone?
Okay. Okay, so here they're telling you what the orders are. It's first order in A. Okay? So okay, so question 2. It's first order of A. That means rate is equal to the rate constant times A times B times C. Okay? First order A, that means I leave it alone. First order B, that means I leave it alone. Second order C. Okay? Do I ever divide anything with rate? No. Okay? So, is the right answer here?
Yes.
Which one is it?
It's B.
Oh, you guys, it's not C. Look what C says. It says the rate constant is equal to ABC squared. Rate equals K, the rate constant, times ABC squared.
See, that's why you're here.
That's why I'm here. Yes. Okay? So, make sure you're reading those correctly. This one sure looks right if I just glance at it. Okay? But it's not, right? That one almost looks right too. What's wrong with this one? The last one. Good. That's right. Say it as sarcastic as you can. There is no K. Okay? There is no K there. That's right. So you cannot choose this one or this one. This is your correct answer.
Where did you get the square?
They told you second order C. Okay? They have to tell you or else you can't assume anything. Okay? And look at the coefficients here. B is squared. So if I was looking at the coefficients, I would have chosen this one. Even though I know it's wrong because there's no K there. Okay? So maybe you wouldn't, and you shouldn't anyways, but that too does not go as your power. Okay? The coefficient is not what you use there as your order. Okay. Any other questions on this chapter? 1-5? Okay, I just got to get out of this. Okay. That's a good one to follow up on this. Okay, so this is equilibrium. Oh, it doesn't like that. Okay, we won't do that. Sorry. Okay, what is the correct equilibrium expression? So it's products over reactants. Okay, so first off, I have to assume, or I have to put NH3 on top. I don't assume. I need to put NH3 on top. Okay, so NH3 is on top here, 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 not here, and not here. So these last three, I can eliminate. Okay, so those ones will not be the correct answer. So it's either A or B.
In the question,
Or C, I'm sorry. A, B, or C.
it says the
D, E.
reversible reaction.
Oh, I see. That one's E. This one's D. Oh, okay, I see. So these last two I would eliminate. So it can be either this one, or this one. Say it again.
In the question, like at the very beginning, it says consider the reversible reaction. Are you supposed to flip it, or is it already in the reverse?
No, it's already, that's what equilibrium means. Equilibrium means that it has a forward and a reverse reaction. So you have to consider that, or you can't write an equilibrium expression. Okay, so here it is.
So when you read
The
it
double
straight
arrow.
across, means you don't have to flip it.
Okay, So consider the reversible reaction, meaning it goes forward and backwards.
Okay.
It's a reversible reaction. Okay? What is the correct expression for the equilibrium constant? KQ is equal to products. Why won't you let me write? It's annoying. Okay? It's the products over the reactants. So it's going to be NH3 on top divided by N2 and H2. So these first three, A, B, and C, all have that. What's wrong with A?
That's the coefficients.
They left the coefficient with NH3 in the brackets, right? That's not how I use the coefficient. How do I use the coefficient? I got to put it out as the power. So it would be NH3 squared. N2, power of 1, H2 cubed. Okay? The only one that matches that is C. Okay? So I would choose C. All the other ones are incorrectly written. Yes?
Can we go over question 20? Because I'm a little confused on the calorie, calorimeter. Now we're in 21, because I think they're connected.
Okay. What's wrong with you? I know what I can do. Okay, here we go. Number 20.
Yes.
Okay. 10 grams of octane are burned in a bomb collimator containing 200 grams of water. How much energy in kilocalories is released if the water temperature increases? So calories, that the specific heat of water in calories is 1 calorie per gram times degrees Celsius. So I'm going to use that. Okay. I have 10 grams of octane, which, let me see. It doesn't really have any bearing on this. Okay, because in a bomb collimator, the water, so if this is my, here's my thermometer. Okay, here's the bomb right here. And the sample's in here, and it's burning, and it's releasing energy to the water out here. Okay, and so I'm getting, this is 200 grams of water. That's changing temperature. This isn't part of this. So this is what I care about, the 200 grams. If it was a solution where the two things were mixed, then I would have to add the masses together. But it's not that. Okay? They're completely separate. So because they're separate, I just take the mass of the thing that's changing temperature. What's the thing that's changing temperature? Water. The water is changing temperature. Okay? So I'm going to take my 200 grams. So Q equals M cat. Okay? I'm going to take my 200 grams of water times my specific heat, 1 calorie per gram times degrees Celsius, times my change in temperature, 37 minus 25. I'm going to get 12 degrees Celsius. Okay? And do I leave it in degrees Celsius?
No.
Okay? How do I know? Look at your units. Look at the units of your constant. What are they in? Degrees Celsius. So they will cancel. So I'm okay. All right? Gas laws, Kelvin. Calorimetry, degrees Celsius. Okay?
So when they give you, that's TP, that's standard temperature, right?
Standard temperature and pressure. 0 Celsius, 273 Kelvin, and 1 atmosphere. That's right. Okay? Times 12, I'm going to get 2,400 calories. 2,400 calories. And then I want to change that to the kilocalories from the calories. There is 1 kilocalorie in every 1,000 calories. Whoa, what am I doing? Calories. Okay? Calories cancel. 2,400 divided by 1,000. I'm going to get 2.4 kilocalories. That looks like a big C. It's not. It's a little C calorie. Okay? All right.
Does 21 go with question 20?
Which of the following will not increase the rate of a reaction? No.
No.
They're not related. Okay? Now, okay, so I know that can be kind of confusing, but if you ever see something that's like this, the problem is that Canvas mixes all the answer choices together. Okay? And so it you no longer know what B and D are. Okay? So what was B is no longer B, and what is D no longer is D. Okay? So how can I answer that question? Well, if 2 of them are correct, any 2 are correct, then this is the right answer. If only 1 of them is correct, then I choose the right thing. Okay, so I have 1, 2, 3, 4 things here. Which of the following will not increase rate, increasing the size of the reaction vessel? No. Okay, increasing the concentration of the reactants? Yes. Increasing the temperature? Yes. Adding a catalyst? Yes. Okay, so which one will not increase the rate? Just this one. Okay, so there are 2 of those things. This one, and this one will increase the rate. That one won't. So it can't be this answer because, which I guess in this case you could have answered, but some of other people would have these in a completely different order. Okay, so if that happens, I'm just telling you right now, if that kind of thing happens to you on the test, then just find the ones. If there's 2 things that are right, choose that answer. If only one of them's right, then choose the right answer. Okay. All right. Oh, I was already there. I have to go back to the review now. Up here. Oh, there it is. Okay. So that was chapter 7, right? This?
Yes.
Okay. So if the signs are opposite, then look at delta H and it will tell you what delta G is. If the signs are the same, then it is temperature dependent. Always temperature dependent. Okay? So that's it. That's all there is to predicting that. If the signs are opposite, delta H will tell you what delta G is. If the signs are the same, then it is temperature dependent.
Could you explain that to the right, to the left?
Le Chatelier's principles? Sure. Okay. So when we're talking about Le Chatelier's principles, anytime you increase something, it shifts away. Right? Anytime you decrease something, it shifts towards. Okay? So we have the left and we have the right. Well, so if I increase something on the left, it's going to shift to the right. If I increase something on the right, it's going to shift to the left. If I decrease something on the left, it's going to shift to the left. If I decrease something on the right, it's going to shift to the right. Okay, that's for concentration. What about temperature? How is it different? That's a trick question. It's not different. It's exactly the same. Okay? Temperature is not any different than concentration. They act the same. If I know where the temperature is written in the question, then I just treat it just the same as anything else. So, for example, plus 270 joules, kilojoules. Okay? So, what type of reaction would this be? Exothermic reaction, because it's releasing energy. Energy is a product of this reaction. So, if I had just told you, instead I said delta H equals 270, what type of reaction is that? That's exothermic? Delta H equals 270 kilojoules per mole. That's endothermic. That's endothermic. That means I would have to write it here because that's a positive 270, right? Delta H positive is endothermic. Delta H negative is exothermic. Okay, so that's how I determine where to write it. If it's an endothermic reaction, I write it here as a reactant. If it's an exothermic reaction, I write it here as a product of that reaction. Okay, so that's going to tell me where to write it, and then I just simply do the same thing. Increase the temperature, it shifts away. Decrease the temperature, it shifts towards. Okay, so as long as I write my temperature correctly into the equation, then I treat it just like it was the concentration of something. If you increase the temperature, it shifts away. If you decrease the temperature, it shifts towards. Okay, and I went through and gave you a number of examples. If this reaction is exothermic and I heat up the reaction, so that means energy is here, okay, and I heat up the reaction, it's going to shift to the left. It's going to shift to the left. Okay, so we have to show where the temperature is so that we can determine which way it's shifting or not. Okay, what about pressure? Look at this. If the pressure is increased, how do I know which way it's going to shift? More moles of gas. So the gas is indicated by G, right? So I need to identify the moles of the gas that are present. How many moles of gas are present on the left side? 4 moles. How about on the right side? 2 moles. So if I increase the pressure, is it going to shift towards 4 moles or towards 2 moles? It's going to shift towards 2 because it wants to bring the pressure back down. So it's going to shift to the side with the least number of moles. If I decrease the pressure, it's going to shift which way? To the side with the more number of moles. So in this case would be 4 moles, or to the right, or left, excuse me. Okay? It shifted to the right when I increased, and it shifted to the right. Okay? All right, let's take a break. And then we will continue. Mostly multiple choice. Yeah, I'd say so. Okay, so let's see, it's chapter 6. Okay, so this is what we're talking about. Okay? Chapter 3, Part 4. Know how to predict the boiling points of ionic, polar, and nonpolar compounds. Okay? So there's these A, B, C, D groups when you're doing that, and they're in order of which ones would have the highest boiling temperatures and which ones would have the lowest. So if you're going to arrange something according to whether it's going to boil at a higher temperature than another thing, first thing you have to do is identify whether it's polar or nonpolar or ionic. But there's always ever only going to be one ionic thing, if anything. Okay? And that one ionic thing would always go right to the top. Okay? So the very first thing is the ionic groups. What is an ionic compound? Okay? Metal plus nonmetal. That's right. Or a polyatomic ion. Non-metal or polyatomic. Okay, so that would be an ionic compound. That's right. Okay, so after that, we get into things that hydrogen bond. What sorts of things hydrogen bond? Okay, so i.e. H2O, NH3, HF. Okay, those would hydrogen bond. Those are things that hydrogen bond. Polar compounds. How do I know if it's a polar compound? Lone pair where? That's right. On the central element. Does this hydrogen is this a polar molecule?
Yes.
Yes, it's a polar molecule. Okay. Is this a polar molecule?
Yes.
No. What am I looking at?
CO2.
It is CO2, but what am I looking at to know if it's polar or nonpolar? Nope.
You're looking for lone pair on a central element.
See how this phosphorus has a lone pair on it?
Yeah.
It's polar. Okay? Does this have a lone pair on it? No, so it's non-polar. That's it. That's all you have to look at, because the reason this is non-polar is because the oxygens are perfectly symmetrical to one another, because there is nothing to disrupt them getting as far away from each other as they can. If I had a lone pair there, that would bend those oxygens down, right? It'd bend them down, and then it would be a polar molecule because I would disrupt the pull for electrons. So here, this oxygen's pulling for electrons, and this oxygen's pulling for electrons. Who wins? Nobody wins, because they're pulling with the exact same force. Okay? So therefore, it's a non-polar molecule. The electrons are distributed perfectly throughout the molecule.
So what if you suck at Lewis structure?
Then you're in trouble.
Yeah, I know they do.
Like there's a double bond on one side, a single bond on the other, like would it still, like just based off of the lone pairs?
Yes. So for something like SO2, you're still just looking at this. Okay? You're just looking at that. These oxygens have been pushed down, so therefore there's a disruption in the symmetry, and so it becomes polar. That is a polar molecule. Okay? Okay? So look at these two polar molecules. How would I know which one is above the other one? They're both polar. How do I know which one has the higher boiling temperature? By their mass. Which one's heavier?
So, light now.
PCO.
This guy has 3 chlorines, right? Those chlorines are heavier than any other element there. Okay? So 3 chlorines and a phosphorus, which in itself is pretty close to the mass of chlorine. Okay? So this is heavier than this. And if you're questioning that, then just, calculate it. Phosphorus, 31. Chlorine, 35.5 times 3. 5.5 times 3. Okay? 106.5. 106.5 plus 31. 137.5. Okay? And then this guy is SO2. 16 times 3 essentially. I'm sorry, not 16. 32 plus 32 plus 32. Okay, I'm going to get 64. 32, 64. Okay? And now you can easily see which one's heavier, right? You can just find the mass. When we were back in chapter 3, we didn't learn how to do that yet, so we were more looking at which things are heavier or whatever. But now that you know how to do this, then just find the mass. And then you're not guessing which one's heavier. You can just determine which one's heavier. Okay? Okay? What about this guy? Polar or nonpolar? Why? There's no central. There's nothing left over to have any central electrons, right? Free electrons. So it's tetrahedral. It's symmetrical. It is a nonpolar molecule. Which one's going to be higher on the list? Between these two nonpolar things.
CH4.
Higher? CH4 is higher or lower? Okay, so let's find the masses of these. Which one's heavier? Carbon and 4 hydrogens, which is what? 12 plus 4, 16. Or 2 oxygens, which is 32, plus 12, which is carbon, right? 32 and 12, I get 44. Carbon dioxide is 44 grams per mole. Okay? So which one's higher? Which one has a higher boiling temperature? CO2. Okay? It's higher on the list. Okay? So first, just follow this arrangement. Ionics are top, hydrogen bonding next, polar compounds after that, and then nonpolar. And in each group of the polar and nonpolars, I'm going to arrange them by mass. Okay? And that's how I'm going to find that. Yes?
If hydrogen bonding is before polar compounds, how come CH4 doesn't count?
CH4 does not hydrogen bond. What are the 3 elements that hydrogen bond? Oxygen, nitrogen, and fluorine. Those 3. Nitrogen, oxygen, and fluorine. That's it. Carbon does not hydrogen bond. Carbon does not have a high enough electronegativity. And in fact, carbons and hydrogens' electronegativities are very similar, hardly different at all. So they end up being very close to nonpolar when they're bound. Okay. Where next, guys? We got 35 minutes. Chapter 8?
Yeah.
Yeah?
Yeah, because you just do have to calculate pH again. You walk through it.
Okay, so you guys will have this available. You're welcome. Okay? You will have this available as a reference material. Okay? So, if I asked you, or I told you that your pOH was 1.8, and I asked you, what is your H plus ion concentration? Okay? And this might be a good thing to do. When you have the question, and you have your diamond, look at it and identify, okay, I'm starting here, and I'm going to here. Okay? Maybe even write it out on your paper. And then write your diamond out, put what you're starting with, where you're going, and then write the equations to get there. Okay? So if I'm going from POH to H+, I have to either go to pH and then H+, or OH and then H+. Okay? It doesn't matter which way. So POH, I'm going to go like this, H+. Okay? POH to pH. What is my equation to go from POH to pH? It's right here. 14 minus the POH. And then from the pH to the H+, 10 to the negative of the pH. Okay? So, if I have a 1.8 POH, what's my pH? 13.2. Okay, so 14 minus 1.8 minus 1.8 is going to give me 13.2. And then I'm going to take 13.2, 10 to the negative 13.2, and that's going to tell me the H+ ion concentration. Okay? Let me see. So, okay, I do have...
14 minus 8 is 12.2. 14 minus 1.8.
Oh, yeah, you're absolutely right. We did 0.2, huh? Is 12.2. 12.2. We're going to get 12.2. Okay? And then we're going to say, whoops, clear. My calculator is different than your guys's. 12.2. I don't even know how to use this very well. There we go. Negative 10 to the x. Okay? And I get 6.3 times 10 to the negative 13. 6.3 times 10 to the negative 13. Okay? Can somebody else try that? Verify that that's what you're getting? So I know it's not just my weird calculator. 6.3 times 10 to the negative 13 is the H+ ion concentration. That's it? Okay? All right. So that's one way. I could have gone the other way. I could have gone from the POH, okay, to the OH minus and then to the H+. Okay, if I go from the POH to the OH minus, I need to do 10 to the negative POH. So my POH is 1.8, so I'd say 1.8 negative. Whoops, that's not the right button. 1.8 negative. Okay, and I get 1.58 times 10 to the negative 2. 1.58 times 10 to the negative 2. And then to get to the H+, I would say 1 times 10. 1 times 10 to the negative 14. Okay, divided by 1 times 10 negative 14 always goes on top. Divided by 1.58 times 10 to the, what was it? Negative 2. Negative 2. Okay? Can I get the same answer?
Yes.
Yeah, I get the exact same answer, right? It doesn't matter which way you go. You're going to get the same answer, either way. Okay? Okay, so this way is 1 times 10 to the negative 14 is always on top, divided by 1.58 times 10 to the negative 2. Okay. So that's how I'm going to use my pH diamond. Okay, what else are you guys worried about with pH? With acid base? Are you okay with conjugates? Conjugate acids? Conjugate bases? So, HSO4 minus? What is the conjugate acid of HSO4 minus? What is it? The acid always has what? More hydrogens. How many more? It always has one more hydrogen. So what is it? H2SO4. There you go. Now you remember. Okay, I was hearing all kinds of answers out there. Okay, H2SO4. Okay, what is the conjugate base of HSO4 minus? Because hydrogens are positively charged, and going to the base is always how many hydrogens? Less. 1. The conjugate base is always 1 hydrogen less than the conjugate acid, right? That's right. Because one of the negative charges is being balanced by this hydrogen. When I remove it, now both of the negative charges are present. Correct. Don't worry about the oxidation reduction part. It's not on there. Okay, if I say you have 0.5 molar HCl, where am I starting here on my diamond? You have a 0.5 molar HCl solution. What's the pOH? Where do I start? 0.5 molar HCl, where do I start? 0.5 molar H plus, right? That's where I start, and I'll go to here, to my pOH. Okay, why? Because HCl is a strong acid, right? Single arrow, meaning I have, well, here it's 0.05 molar HCl, so I'd have 0.05 molar H plus and 0.05 molar Cl minus. So to find the pH, I would take the negative log of 0.05 of that HCl solution, correct? 0.05 molar sodium hydroxide. 0.05 molar sodium, 0.05 molar hydroxide. Okay, so the pOH is equal to the negative log of 0.05. So if it's strong acid or strong base, that means it dissociates 100%, and I know exactly what the concentration is. Now, would I ever ask you what is the pH of a 0.01 molar solution of acetic acid, which is a weak acid? I wouldn't do that. Okay? So if I give you the concentration of the acid, and I'm asking you to find the pH, what do you know about that acid?
It's a strong acid.
It's a strong acid, so you can find the pH directly from the molarity. All right, that's what you know, because I'm not going to give you the molarity of a weak acid and ask you to find the pH. Although that's lots of fun. Okay, it's not part of this class. Okay. Titrations. You're just simply using that equation, okay? So under our reference materials, you'll have the titration equation, right? So you'll be able to use it. MAVA equals NBVB. So you'll just identify how much volume of the base you titrated into the unknown acid, and then knowing the initial volume of the acid, you'll be able to say the molarity of the acid is equal to the molarity of the base times the volume of the base divided by the volume of the acid. Okay, and solve for M of A.
multiply the masses by the percent abundance, the percent abundance would be given in the question.
Yes, it would. They would tell you what they are. So it'd be the mass times the percent. Okay? And then, so in this example, they gave us oxygen 15, 16, and 17. So those are the masses, 15, 16, and 17. Okay? And then they would tell me the percent abundances. So we would assume, obviously 16 is the most abundant. So it's going to be something like 94%. Let's say 15 is 2%, and 17 would be 4%. Okay? And so you'd say, but I don't use 2. I don't use a 2 there. What do I use? 0.02, 0.94, and 0.04. Okay? And that 15 times 0.02, 16 times 0.94, 17 times 0.04, 15 times 0.02, okay, 0.3, 16 times 0.94, 15.04, and then 17 times 0.04. And then I just add them together. 0.56 plus 15.04 plus 0.3. Okay, which should be around what I'm seeing here on the periodic table. If it's something on the periodic table. If it's not a theoretical element. Okay, that's how I'm going to find the percent abundance. The average atomic mass. So I'm going to say this is the weight. How you guys doing with naming? Doing okay? Okay, let me ask you this then. What's the name of this?
Something outside.
Okay, it's something oxide. Manganese. Manganese 2 oxide is close. Manganese 4. Manganese 4 oxide. Do you think manganese 2 oxide would be an answer choice?
Yeah.
Yeah, probably. Do you think manganese dioxide is going to be an answer choice? Yeah, probably.
What is it for again?
Okay, so what's the charge of an oxygen?
2
Negative 2 times 2 is negative 4. What's the positive side?
Okay.
Plus 4. So there's 4 positive charges on that manganese, and they're distributed onto 1 manganese. So that 1 manganese has 4 positive charges. Okay, so when do I know when it can't switch back?
When you don't have.
When I only have 1 subscript. That's right. Okay, 1 subscript means be careful. It might not switch back. Okay. What's that one? Iron 3 phosphate? Iron 2 phosphate. Iron 2, not 3. Because the 2 stands for what? The charge, not the number of irons. It stands for the charge on the iron. Okay? Do these switch back? Yes, there's 2 of them. They're going to switch back. Iron 2. This is iron 2. Can I just calculate? You can calculate it. Okay? Phosphate has -3. -3 times 2 is -6. So this side is +6, but there's 3 of them. So 6 divided by 3 is +2. So this is iron 2 phosphate. Okay. That's nitrate. Does nitrate have lone pairs on the central element?
Yes.
How am I going to draw it?
It's a trigonal planar.
I don't know yet because I haven't drawn it. So we have to draw it first before we can identify the shape or the number of lone pairs on the central element or any of that other thing. Okay?
Oxygen is going to be central.
Oxygen.
Yeah. Is that the one that would what?
Nitrogen, the least electronegative element goes in the middle. So nitrogen is less electronegative than oxygen. But just look at it. Which one would you think would go in the middle? Nitrogen is surrounded by 3 oxygens. Okay? It's mostly that. Just look at it and you'll be able to tell which one's in the middle. Okay?
There was one, I remember, that it was like 2 something, but it was not the central, like oxygen was the central. And it branched off to something else.
I'd have to look at the example.
So that worksheet one?
Yeah, remember?
Yeah, but it was the nitrogen had like no
Okay, so nitrogen has how many valence electrons? 5. Oxygen has how many valence electrons? 6 times 3?
18. Well, 19. Because of the negative.
Okay, that's right. We'll get there. But your 18 is right. Okay, 18 plus 5?
21.
23, right? Plus 1 more, because you're right, because we have a negative charge. That means I have 24 valence electrons, right? So nitrogen in the middle, surrounded by 3 oxygens. How do I start? My
Put the pairs on all the O's. Oxygen.
and on nitrogen.
Yeah.
I have to put it on everything. I have to show everything following the rule of 8. That's my skeletal beginning structure. No double bonds. Everything following the rule of 8. I have 24 valence electrons that I need in my structure. How many valence electrons are in the structure as it's drawn right now? 26. Each oxygen has 8. There's 3 oxygens. That's 3 times 8 is 24. Plus the 2 in the central element. That's 26. Okay? How do I remove electrons?
double bond with an oxygen.
Good. Could I do this?
No.
Why not?
Because you do double bonds.
Okay? That's true. Because I'm not sharing electrons. And I can't just remove electrons because am I still following the rule of 8? No, I can't do that. So I have to make a bond and remove electrons from both of the things that I bonded to. How many electrons are in my structure now? 24. Is this my structure?
Yes.
Yes, this is it. Is it? What is the shape of this? The geometry of it?
Trigonal planar.
Trigonal planar. Okay, what if it had the central electrons? What shape would it be? Trigonal pyramidal. Okay, good.
How about CO2?
Okay, so carbon, 2 oxygens. We have 4 valence electrons on carbon, 6 on oxygen. 6 times 2 is 12. That's 16 valence electrons, right? Carbon in the middle, surrounded by 2 oxygens. Start everything out with 8. 2 times 8,
I said CO2.
Cl2. Oh. Okay. So we have Cl2, carbon, or chlorine, bonded to another chlorine. How many valence electrons do I need? 7 times 2 is?
14.
How many are in the structure as it is? 14. So that's my structure.
Okay, now take a Cl and then add 2 oxygens.
ClO2, ClO2, like that? Okay, is there a charge?
Yes.
Negative, right? Okay. So now we're going to take chlorine, surrounded by 2 oxygens. Okay, we have chlorine has 7 valence electrons. O2 is 6 times 2, which is 12. Okay, we have 12 plus 7, 19, plus 1 more, 20. Right? How many are in my structure right now? 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. That's my structure.
If you do CO2, it's -2 carbonite. I had that on a homework and
Like that?
yeah.
Okay, carbon, 4, oxygen, 2, 16. I'm sorry, not 16. 12. Taking no oxygen. Okay. So 12 plus 4, 16. Okay, but plus 2, it's going to be 18. Okay, so carbon surrounded by oxygen, surrounded by oxygen. There's 20.
Oh.
What do I do?
You make the double bond with.
Double bond. Now what?
You erase one of the oxygen pairs and the carbon pair.
Okay, now how many electrons do I have?
18.
That's my structure.
And what is
And
the
it-
exception like to the rule of 8?
The exceptions to the rule of 8 could only be on elements that are past the first row. That means they have to be in the 3rd energy level. So SiP, S, Cl, anything after that, those guys and anything later could have exceptions to the rule of 8. And the way that you know that there are exceptions is that if you draw the structure and you have, so in this case I would have 22 electrons, and I would draw this and it would have 20, and I should have 22. I'd have to add those extra electrons onto the central element. Okay, but you guys aren't really doing, you shouldn't be doing anything like that on the test. Okay. So what is the shape of this one?
Bent.
Bent. That one's bent. How about this one?
Bent.
It's also bent because it has electrons on the central element. If you have electrons on the central element, you're bent. Carbon dioxide, which I never finished here, okay, would look like this, and it would be linear. Yikes. Too many off of here. Okay, that would be linear. Okay. What about HF?
Linear.
Linear. Is carbon dioxide polar or nonpolar?
Non-polar.
Nonpolar. Okay. Is chlorine polar or non-polar?
Neither.
Oh, it's definitely one of them.
Okay.
There's no central element, so it is nonpolar because it's bonded to itself. If it was bonded to something else, like HF, fluorine is more electronegative than hydrogen, so therefore it is polar. Chlorine is nonpolar. Nonpolar, nonpolar. This guy's polar. Okay? What is that? Chlorite. Yeah, chlorite, ClO2 minus. Polar or nonpolar?
Polar.
Okay. We would say it was polar, but in reality it's ionic, so it's neither polar nor nonpolar. But if we were describing it, whether it's polar or nonpolar based on the shape, we would say it's polar because of the central element having electrons on it. Okay. This one too. It's ionic, but anyways. How about electron configurations? You guys okay with that? Okay. Good. What are the exceptions to naming transition metals with Roman numerals? Good. Zinc, cadmium, and silver. Okay? Those are the three transition metals that you do not have to state the charge, okay, in the name, because they're always zinc 2 plus, cadmium 2 plus, silver plus. It's always that. So you don't have to state it, okay, in the name. And those three are right there, labeled for you. Okay. Okay.
I have a question about talking about what are the dipole forces?
So dipole forces are between polar molecules. So if you had two things that were polar, then they would attract to one another from positive end to negative ends, and they would attract. And those are intermolecular attractions, and we call those attractions dipole forces. Okay? Now, you have hydrogen bonding, which is the strongest type of dipole force, which only occurs on nitrogen, oxygen, and fluorine that are bonded to a hydrogen. Okay? Then you can get hydrogen bonding. Nonpolar molecules only have London forces. Okay? Polar molecules also have London forces, but the majority of their force is going to come from the dipole force.
On the test, are they going to be like 80 questions since it's both? Like,
It's going to be more like 70 something. 74 maybe. Yes, that's the situation. These are your last 5 minutes.
Can we go over real quick chemical and physical change?
Okay, so a chemical change would always result in a new substance. So H2 plus O2 producing H2O. Okay, this is new. So if I just look at this side, I have H2 and O2. I don't have water over there. So because I produce something new, that's a chemical change. It's a chemical change. But H2O liquid going to H2O gas, that's a physical change. Why? Because it's the same substance, right? The substance hasn't changed, just its physical state. So a chemical change would always result in something new being created.
So if you deep fry an egg, that's a physical change.
Yeah.
All right.
Because the proteins are denaturing and they're stacking on one another. That's just a physical change. But if you if you react those with something and you change them into something completely different, then that would be chemical. That reminded me of this video my wife showed me yesterday. It was like some let me see. I bet I have it. Acapella science. So this is called this one. Molecular shape of you.
God isn't the best way to try to sum up how electrons come and go. They are the states of a matter field that follows an equation, the Dirac road. The Schrodinger part of the whole equation will just lead and succeed when it expands. Now they may move from an editing with the proton and watch them start to dance. It's hydrogen and psycho proton. I feel your joy. Zero potential, lift down, pulling on me. But I'm not pulling it deep. Know that we'll break uncertain.
Pretty good, right? I wish I would have thought of it.
Orbitals take the shape they do. The stable states of the quantum rules. And when one approaches two, they combine and they're bonding.
All right. Well, you guys can watch this another time, but
I give him credit.
Yeah, he did a good job. I'm looking at like all this different ones.
He's like last semester my history class.
all right. So if you have any other last questions, you can come see me and ask them.
Will you be on campus Wednesday?
I will be on campus at Wednesday, 10. Okay, let's just meet in here, 10:30. Right here, this classroom. On Wednesday.
Hey, I was like, do I want to come?
Thursday is your test. So you're definitely meeting in here on Thursday. Yes. Wednesday at 10:30 and
So that's wrong.
That's a motivation.
It's another way that you could also do it.
oh, what do you mean?
Like the way
That's not wrong. That's exactly what we drew, except that you're just showing the electrons in a different place. Like I had them up here and down here and straight across. But that I can draw it like this, and it's exactly the same thing. I still have the same number of electrons and everything around it.
Can we take the quiz as many times as we want, or only 2 attempts? Quiz 1. It's limited.
Can you take the quiz what?
The quiz 1, is it limited?
It's unlimited attempts.
Oh.
I keep saying I'll do it, but I feel like it's good enough to like tell myself to do it.
But the final, 1 attempt. So come ready, guys. And have a good 4th of July. Not stressing out about your test, right?